Hello and welcome to my video, lesson 1.7 on equalities. If you look at the word equality, you will notice that it starts with equal. So if you think about math and the word equal, we use the word equal when we have an equals sign. So we can say such and such equals such and such. So for example, if we have 3, make that a nice 3. 3 plus 5, we say it's equal to 8. So an equality is just a fancy way of saying that we have an equal sign. One side is the same as another side. They're equal sides from one side to the other. Now for 1.7, we look at this thing called the commutative property. And so there are two operations that use the commutative property. To show the first one, we have addition. So A plus B equals B plus A. So to show this, I'm going to draw a line and add something to it. So if this, well, maybe let's use the squares that we actually have. If A is 2 squares long, and B is 3 squares long, well, this represents A plus B. If we flip them around, then we have 1, 2, 3 squares long, and then 2 squares long. Well, this is B plus A. And you can imagine that it doesn't matter what the number is. We can flip them around. It doesn't matter if we have 3 plus 4. We can write it as 4 plus 3, or we can substitute any number in here for A and any number for B, and this will be true. So this is the commutative property of addition. And this also works for multiplication. Just thinking ahead before we finish writing this commutative property, what is multiplication when we think physically? Well, we thinking about multiplication, the best way of looking at multiplication is by looking at the area produced from a rectangle. So if A is this, well, maybe let's use the same value. A is this one and B is this one. Well, the area inside this is A times B. And so, if you just flip those around, so have B times A, well, all you're doing is you're rotating your rectangle. So instead of having the short side top and bottom, short side is side to side. So A is on this side and B is on this side now. This just represents B times A. Now if you count the number of squares inside, I'll just do that with yellow. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Well, either one, even if you rotate the rectangle, they're going to be equal. So this is the commutative property for both addition and multiplication. So now, with that in mind, I just want to get you thinking about subtraction and division. So let's think about subtraction first. Is subtraction commutative? If we have A minus B, if we have A minus B, can we make that B minus A? And does that work every time? Well, let's think about, again, lines, just like we had before. So if A is 3 squares long, and we subtract B, which is 2 squares, well, all we are left with is 1 square. Okay, not too shocking. But if we do it the other way, where we have 2 squares, and we take away 3 squares, well, we're left with, so this one is left with 1, and this one is left with -1. So actually, they are different values if we subtract one from the other or the opposite way around. So that's subtraction. And last but not least, we have division. So if we can take A divided by B, can we make that equal to B divided by A? Well, remembering that division is just the opposite of multiplication, if, for example, we have a rectangle like this, and the number of squares inside is A. This is the number of total squares inside, which is 8 in this case. And we want to divide by B, which is, we'll say this side. The answer to that would be on this side, answer. Right? Which would be 2. So 8 divided by 4 is 2. Well, that's fine. This would be equal to 2. But if we tried to do it the other way around, and we had 4 squares, and we try to divide that by 8, so this is B, we tried to divide that by 8, first of all, it's hard to do, but let's try to do that. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all the parts are equal, but you can see it's not going to be a super easily defined number. So it's not the same. Each part here is actually half a square, equals half a square, 0.5. So you can see that those are definitely not the same number, 0.5 and 2. They're actually inverse numbers. And same with those ones, those are also inverse numbers. So what you can see here is that we have the commutative property for addition and multiplication, but not for subtraction and division. I hope this video helps for 1.7 equalities. Good luck.